right. We are probably live. I would give it a 70% chance we are live. So, Richard, thanks for coming on. Appreciate you taking the time to have a conversation with me. Would you mind telling us a little bit about yourself before we get started?
Yeah, hi, I'm Richard Brown. I think this is the fifth time I've talked to you on your channel, possibly. So, my day job is teaching philosophy at the City University of New York, and my spare time includes hanging out online and talking about more philosophy.
I thought you were a professional skateboarder.
Professional, no, amateur skateboarder, absolutely. Amateur skateboarder, professional philosopher.
Gotcha.
Yeah, I've been
So which one
skateboarding for
pays
3
more?
years now after a 30-year break or so.
Gotcha. Which one pays more? About the
Which
same?
one pays more? Well, in terms of self-confidence and overall feeling of like accomplishment, I'd say skateboarding. But in terms of paying the bills, philosophy.
Gotcha.
But I definitely feel, philosophy is difficult, and I'm not the most smart person, but at least skateboarding, I can set goals and try to achieve them. I'll never be a great skateboarder, I know that for sure, but I'll be an adequate skateboarder.
Cool. Cool. All right. So we're going to talk about the rule following argument. Could you give us an overview of the rule following argument, specifically what are the implications of the argument? Like, supposedly it means that meaning isn't how we think of it or something, and what exactly does that mean?
Yeah. Okay. Yeah. Well, I mean, we've talked about this before, so this is like a follow-up on that. But uh, oh yeah, this is live. I mean, you guys can tell by the hair, right? So
Could you edit your hair in post-production if it wasn't live?
yeah, exactly. Yes, that'd be very good. So, first I was going to ask you if you've changed your mind on any of this stuff, or are we sort of starting from where we left off?
Probably the same, I think. I don't think I've changed much. I think that the position is essentially I don't see the problems with the rule following argument, what it's supposed to state any way that's different than like the matrix. I think last time I used the analogy of the matrix argument that like we could be in the matrix and so everything's wrong or whatever. And I don't see the rule following argument as anything different fundamentally. It seems like if we were in the matrix, then everything we thought we were doing 5 seconds ago could be totally wrong, or the evolutionary argument from Plantinga, where we're on a lily pad or frog on a leaf, doing one thing, what we think we're doing something else. Seems like an analogous argument to these two things. And I don't see the fundamental difference or what implications it has.
Mhm. Okay. So my goal is not to convince you to be a meaning skeptic. I don't think anyone really is a meaning skeptic. My goal is simply to talk about the argument so that you understand it, and then you could say what your view is. Because I felt like last time, even after we talked and we emailed a bit, you were saying you don't really quite see what the relevance or force of the argument is supposed to be. So that's mostly what I'm concerned about. And also, just to set a couple of ground rules, we're not looking for a tea jumpster fire today. No jumpster fires. Looking for a civilized conversation, which I admit last time was my fault mostly that it wasn't, but we're trying harder to be nice. So the basic argument is very simple. You take any predicate that you like, any function that you like, and you think of an alternative meaning for that function. So for example, with addition, it's quaddition. But with any other predicate, you could do the same thing. So you could take blue and turn it into grew. Are you familiar with grew?
Yes.
Okay, so grew and blue have as their similarity that they overlap within a certain context. So something is grew, let's say, if it's green up until the year 2024 or blue afterwards. So and that can be done for any word at all. So if you want to take the word intention, you can invent the smintension, where to smintend is to intend as you normally would up until Tuesday, or whatever day today is, I forget, up until Sunday. And then, except on Mondays, it would be doing the opposite. So you can always make any kind of gerrymandered predicate that you want. defined in these arbitrary ways using disjunctions, so that it's fairly weak. So that
I did have a
focusing
question
on,
real quick
oh
on this
yeah,
part. So,
uh,
what is the significance of using some period of time t and then after tx? Why not just say the word means something completely different, like the evolutionary argument where we think we're, I don't know, running and we're really on a lily pad on a frog or something? Why is there any relevance to this time part and just make it, instead of making it just a completely different meaning altogether?
because we want it to be true now. So the GRU predicate is, if you take something, so this thing right here is not GRU. It's blue, but maybe tomorrow will be GRU. So the green things are the things which you would identify as green. The GRU things are the green things up until a specific date, or blue after that date. So the kind of idea of sectioning it is to make sure that there's some way we could say that there's an accurate or correct part, and then the inaccurate or incorrect part comes at a later time.
Well, so I still don't see why we couldn't just say, like, the statement, I am holding a phone. Either that statement is true now, or we're in the matrix, this is false. And the separation between the two statements and their truth and falsity seems to be, in a sense, the same, because like either way, one of the statements is true and one of the statements is false. Just like this object is either truly green or truly GRU.
Yeah, I mean, I guess in that way, it's fine, but I would disagree with whether it's true or not that there's a phone in the matrix. But I think maybe we could talk about that later if you want to. But I think it would be true in the matrix that there is a phone. So basic. Any way you want to define these things, I take your point. Any way you want to define these things. Um, the question is, how do you know which one that you meant at a certain time? And the traditional argument always begins by considering your past history. So, in the past, you were thinking you were adding. The skeptic comes in the past, you weren't doing quaddition or quadding. And you ask, what is quaddition? They say, well, it's all the normal stuff up to a certain number. And then after that, 5. So take any sort of numbers that you're not used to adding. So up until that number, it's the regular sort of function of addition, or it returns the value of 5 after that. So the question is, what fact about you could make it the case that you meant addition as opposed to quaddition, or that you meant blue as opposed to GRU, or that you meant any of these things that you standardly took yourself to mean, as opposed to these non-standard gerrymandered kinds of things. That's
And
the
so my
basic
first
puzzle.
intuition, is, well, that's simple. Is look into your brain. Your brain, either your brain or reality is going to physically determine what you meant, because meaning, uh, as I understand it, is whatever is determining you to do the action in the first place. So if I meant to do rule one, what that means is that there's something in my brain. Rule one is in my neurology, or it is in the laws of physics, and it is causing me to do that rule. And therefore, I couldn't be doing the other rule, because the rule that I'm doing is determined by either my brain or physics. And so we can know, to answer the question, what is it about me that determines rule one over rule two? Well, there's something biologically or physically that solves the problem. There's no problem.
Mhm.
That's
So
my
how would the
intuition.
rule determine it
Well,
in
so
this
like
rule
say,
one sense of written down?
well, so let's I'll go with rule two just because it's easier to understand. Say I'm
Okay.
doing the rule that after number 52, everything is 5 or something. If I'm following that rule and I've still only gotten to like 30 or whatever, there's some part in my brain that once I hit 55, or some part in physics that once I hit 55, the next number will be 5. And that has to be written as like a coding program somewhere in my brain. Um, that I know about, either through society. Society has taught this to me, that after I get 50, 52, I go to 5, or that somehow in the laws of physics, it determines that after every computer gets up to that number, it just happens to go to 5. And that's just the law of the universe or something. And so it's determined, and it's built into either my brain, knowingly or unknowingly, that it will occur. And that this part of the rule has to be baked into either my brain or physics in order for me to be following that rule.
Okay, so the first thing is that I think when I hear you say that, it sounds to me like you're saying maybe two different things. So on the one hand, well, traditionally we wanted to distinguish between what they call skeptical solutions and so-called straight solutions, non-skeptical ones. So non-skeptical solutions try to actually find some meaning constituting fact, something which would make it the case that you meant one versus the other, which is sort of what Kripke proposed in the original Kripkenstein book. Always look for a kind of skeptical solution, which is to say, yeah, okay, so it's got to be something about the community, something about the context that you're in. It's merely that you're raised in a certain environment where you were taught to go on in this way or something like that. But there's no fact of the matter about you independent of the context or the community, which would make a case. So in other words, this is kind of, like Hume's skeptical solution to the problem of induction or something like that is supposed to be kind of admitting that there's no objective thing and appealing to these contextual things. So part of what you said sounds like you're doing that as well. And in fact, when I first heard you talk about this with whoever, Jack Angstrich or somebody, I forget, way back when, that's what it sounded like to me as well back then. That's what started this whole thing. That's why I wanted to talk to you about this, because it sounded like what you were saying was, look, you have the CD. The CD can be, player and read. That's like the context. But absent the computer, which could read out the CD, you can't really answer the question just by looking at the CD itself. And that, in a way, to me, admits that there's a challenge here, and that you can only get the skeptical solution. So I wasn't sure which one of those you really were meaning, whether you were trying to go for like a so-called non-skeptical solution, or whether you are okay with this more skeptical kind of take. That is the context that's important.
I guess I would try to translate that into more like the brain analogy. So the programming on the disk is going to be determined by the society, so it's arbitrary. But what the disk is trying to accomplish wouldn't be arbitrary at that point. It would be like, given my societal programming, when I do this thing, I'm expecting this result. And that's in the program. That's in the CD. The CD is expecting a result. It's programmed for Windows or whatever. And so if I program the CD for Windows, it's physically determined that I'm expecting this result. And so I can similarly look at my brain or look at my the laws of physics or whatever and say, I'm following this pattern because I've been programmed with this pattern with this expected result, and therefore that answers the question. This is the rule I'm following. And so I wouldn't see a difference there. So I see like there's obviously the societal arbitrary programming that's input into my brain, but then once it gets onto my brain or the CD, there is now a physically fact about me and about the CD, which is programmed in there, that does determine which rule I'm following. Because a CD doesn't know what programming is doing, that obviously, but human brains do. Like when we add numbers, we know we're trying to get to the next number. Like if supposedly we get to 55 and it changes to 5, and the elementary school teachers didn't tell us this, they would have failed at their job. They're supposed to tell us what the next number is. And so if there's some key rule in the system that we're supposed to be following, that would have to have been told to the people who would be following it. Otherwise, they can't be following that rule because they're following the other one, the one that doesn't have this change.
Mm-hmm. So in what sense are you following the rule in the way that you're talking about it right now?
So like
Because
if
it
I
sounds
was
like what you're
taught,
saying is just some determinate process which causes you to make a certain utterance. Doesn't sound like following a rule.
well, so like I would say if elementary school teacher told me that after you get to 55, she's teaching me addition. She said after you get to 55, every number after that is 5 or whatever. Then I would know this in my brain. And so when I was doing addition, I would be following this rule. I'd be like, okay, 54 or 1, 2, 3, 4. And I'd be like, yes, so when I get to 55, I have this knowledge in my brain that it just goes to 5. So I'd be following the rule because I know my brain has been programmed to, after I hit that number, go to 5. Just like I could write into a computer, after you get to a certain number, revert to 5. And so we know what rule the computer is following because it's literally programmed right there into the computer. Once you get to 55, go to 5. And the same programming exists in my brain because I've been taught that. or the lack of being taught that means I'd be following the alternative rule. And so I could know what rule I'm following the same way I could know what rule the computer is following, because it's literally programmed into the computer, do this one, not that one.
So just so I understand, when you say that you were taught addition in elementary school, what do you think you were taught?
What do I think I was taught?
Yes. What did they teach you to do?
Well, in this analogy, I'm taking it from the perspective of the quaddition. Say I was taught quaddition. For me to have been
Uh-huh.
taught quaddition, they have to teach me, here is the point where it changes. And so that is a fact that is in my brain that I've been taught to do. And if that fact hasn't been taught to me, then I can't be doing quaddition.
Why not?
Because I haven't been taught there's a change, therefore I'm following whatever the alternative rule is where there's no change. And so
So
I'd be
how do
following
we
that
know?
version.
So let's say I'm the elementary school teacher and I'm trying to teach you addition. I don't teach you how to add numbers all the way up to alpha naught.
Sure.
They always stop at some arbitrary point. So maybe the hundreds, maybe the thousands, maybe the hundreds of thousands, but they don't teach you how to add 500,364,926 plus a googolplex. I mean, they just don't teach you that sort of stuff. You're supposed to like carry on in the sort of same way. And it's that carrying on in the same way that if your society expects a certain answer, that's the skeptical solution. To say, well, all we mean by following the rule is doing what other people in your community expect you to do. So that's the kind of solution, that's the skeptical solution. Because it doesn't, so I guess the kind of ground rules of the debate are we're looking for two things. We're looking for something that's going to make it the case that you are doing addition versus quaddition, but also something that in your mind justifies your answer, that you could appeal to and say, look, this is the reason why I carried on in one way versus the other. So in the case of the elementary school teacher, they may be merely teaching you quaddition, but they just never got up to the point where it changes. Lots of times in math, they wait until you get to a higher level of math to introduce some new function, some new way of thinking of things, etc. So if you ask an elementary school kid about negative numbers, they tend to say, "What are you talking about?" Some of them discovered on their own, perhaps, but they're not taught about that stuff till later. So how do we know that the elementary school isn't teaching you quaddition, namely the part that is addition up until it changes? So that
Well,
you would be
so
carrying on doing what they're doing, but then when you get to a certain point, I mean, the whole skeptical point kind of assumes that your whole past history of adding is consistent with also quadding. And it sounds like what you're saying is you don't think that that part is true. So that's what I'm trying to get at.
yeah, I don't think that part is possible. So like in the elementary school example, suppose they're trying to teach me quaddition, they just never got to the point that it gets back to 5, then I just
Mhm.
wouldn't be doing quaddition, because one of the key rules of quaddition they didn't teach me. So I'm not doing quaddition because they haven't taught me the key rule of what makes something quaddition and not quaddition. So I'd be doing the alternative because I'm incorrectly doing quaddition, which therefore would mean I'd correctly be doing not addition or something. And so it
So,
seems like
but I'll try. Go ahead. Yeah.
so it seems like the determining factor is whoever's doing the programming is going to program me to do one rather than the other, whether they intend to or not. So their intention, I don't think, makes a difference. I'm going to be programmed in such a way that I'm going to follow one of these patterns. And by looking at my programming, I can know which pattern I'm following. So like I think looking at it from a perspective of a computer rather than a person makes it easier. The computer is going to do one or the other. And so we can know which one the computer is going to do either by looking at the programming and say this is exactly what it's going to do, and we can know exactly what's going to happen when it goes to 55, or we can know by looking at the laws of physics that it just determined that when things get to 56 they go to 5 or whatever, and so we can know either way what's going to happen. And so why would we where's the ambiguity when looking at it from the perspective of a computer? We would just look at its programming and know which one, right? So why would that not work in this case for a human by looking at their brain programming in the same sense?
So when it comes to computers, we program them. And that's so we input the thing that we want it to be doing. But if a calculator fell from the sky, like, and it came from Alpha Centauri or something like that, and we had good reason to believe that it came from Alpha Centauri, then what fact about that calculator would determine whether it's doing quaddition or addition, especially given that calculators are finite devices that will return an error result once you get to too big a number. So what about that thing would make it the case that how would you apply this answer to that?
Let's look at the programming. I think we could still take a calculator, look at the programming, and then know what it's going to do, when it's going to give the error message, which rules it's following. So supposedly the Alpha Centauri analogy is meant to show that we can't look at the programming because it's in a different language or something. But since
Well,
it's a
it's meant to
calculator,
show that we don't know what the program is.
sure. And so, but I think that whether or not we know what the program is seems like a separate question to the first question, which is there a fact about the calculator that we can look at to know which rule it's following? And I would say yes. If there was a calculator that fell from Alpha Centauri, whether or not we could know it, there is programming in that calculator. And if we could read it, it would tell us for a fact of the matter which one it's following. We'd be able to answer that question.
So I mean, brings up the other kind of related point to this, which is that the skeptical argument's also supposed to apply to programming machines, and Kripke kind of uses this as an argument against functionalism to suggest that we can't be implementing some kind of program or something like this because we can't really tell what. So the skeptical challenge is that you can never be sure that the error message that you receive is really telling you what you think it is, as opposed to being part of the computation. So Kripke says, look, if a machine breaks down, then you would say, look, it's broken. But someone who's really clever and really good at designing things may have built that into the design so that the physical breaking might be part of his computing some other function.
Sure, I would agree, but I'm still focused on that main question. Is there something about the calculator that we could look at that could tell us which language it's using? And the answer would still seem to be yes.
Which thing would it be?
Programming, that the physical computing language, whether it's binary or some kind of physical system in it, we should be able to look at the physical switches in the calculator to know what thing it's going to do in any given situation, and we could just say this is the one it's doing
In any given situation, even in ones that it will break down, and even ones that are too big.
Yeah.
I mean,
Yes, I think
how
that if we look at the programming of any calculator, we should be able to know exactly what it's going to do in any given situation at all.
that's assuming that you know what the program is. So the question is,
Well,
so
does it?
yes.
But because even if I don't know what the program is, the question is there something about the program, whether I know it or not, is there something about the calculator that determines what language it's doing? And I think necessarily there either has to be. I think necessarily anything the calculator is going to do has to be determined by the physical parts of the calculator. I'm a physicalist, naturalist, think all there is physical stuff. So anything the calculator is going to do is going to be physically determined by the physical parts of the calculator. So the programming is just an analogy to, say, the physical dominoes that have been set up in the calculator. And so if I know the programming, then I know all of the possible things it could ever do and what it's going to do in any situation. Now, I may not be able to know that, but whether or not I'm able to know that seems to be a separate issue to the question, which is there something about the calculator that will determine which language it's following? And I think the answer is obviously yes, there has to be. It's all physically determined. And so barring quantum mechanics, random fluctuations, yeah, there's got to be one determined way it's going one way or the other.
But that won't determine, I mean, even if you grant that, which I think there's a reason you could challenge that, but even if you grant that, it's not going to nail down that it's addition versus quaddition for numbers that can't calculate. So if you say, here's the calculator, it has internal states X, Y, and Z, and internal states X, Y, and Z transition to states X prime, Z prime, and Y prime, or whatever, and you map all of that stuff out, that still may just be the part of the quaddition function, which overlaps with addition. So why think that you could extrapolate from there to things that it isn't able to add and say, well, it would do the same thing then?
Well, so I think for it to be doing quaddition, there would have to be programmed into the calculator some kind of transition. Say it couldn't get to 52. It was just too small, didn't have enough binary switches or whatever. In order for it to be doing quaddition, you would have to say there was some programming in there that says if get to 52, go to 5, even if it was impossible for it to do this. Otherwise, it can't be doing quaddition because it doesn't have the rule of quaddition is doing the other one. And so if we gave it more processing power and let it continue, if it didn't already entail this rule once 55 go to 5, then it would do the opposite. It would do the alternative rule, because that rule is programmed into it. And so it seems like unless the alternative rule is already pre-programmed into the calculator, then it must all be following the other one because it's going to be doing the other one necessarily.
Well, so why not interpret the error as it doing quaddition at that point? I mean, so it can't return those values for it. So it's always, every calculator is built to just work on some finite set of the number system. And, you know, I mean, abstracting away that we built this program, so we know what program put into it, that's kind of cheating a little bit. But if you just start like literally from not knowing what the original designer had in mind, then it's sort of question begging to say the original designer had in mind this function as opposed to that function just by looking at what it is able to do.
Sure. Oh, I would agree. So I wouldn't, because if we get the error message, that doesn't tell us one way or the other. I would say you'd have to look at the programming and have in the programming, it's going to have to say all of the things it can do. And then you could say, well, it stops at 52 or something. Well, let's say if we look at the pattern prior to that and continue that pattern, in anywhere in that prior pattern doesn't entail a change. The answer would be presumably no, because it didn't have the processing power. And then you could say there's a quaddition calculator, and then it'd say it would entail a change at some point. There would be in programmed, even if it wasn't able to get to the number, it would say at this big number do a change. And so we could look at the programming and know which ones what it's going to do, and so we could know which system it's following. And so it would, even though the intention, I don't really care about the intention of the designer because that doesn't matter, because someone could intend to do quaddition and accidentally do addition or whatever. But we could look at the physical system of the calculator and know what it's going to do by saying if it has an exception clause to do something different at some point. Whether or not it reaches that point, it doesn't make a difference, because if it's not programmed to do an exception, then it won't do the exception. If it is programmed to do the exception, then it will do the exception. And so whether or not there's that exception clause gives us a determining factor to know which system it's following, it seems like.
Yeah, but why would the exception clause have to be built in in order for, I mean, so if you're building something that is just supposed to add numbers up to 52 and quaddition kicks in at 55, then why would you build in the exception rule? Because you're just kind of, the designer is just trying to capture a part of it, which is, overlaps with the other function.
Sure. Well, you build in the exception rule to make sure it's following quaddition. If it didn't do that, it wouldn't be following quaddition. So like if I teach a elementary school kid to add things up and I just don't tell them that once you get to 52, it goes to 5, well, then they won't be following quaddition. They know which rule they're following. They're following the not quaddition rule because they aren't including that exception rule that is required to make something quaddition. And so if that exception rule is included in there, if I tell you once you get to 55, do 5, even when they're doing the 1 + 2 + 3 to get to 6, they're following quaddition. We know they're following quaddition because they have that rule built in that once you get to 55, go to 5. And so we can know whether or not they're following one rule or the other based on whether or not this exception rule has already been built into their programming.
Do you think the non-exception rule is built into regular addition?
Maybe.
I mean, otherwise it doesn't seem like you could say that the calculator is really adding if there's nowhere explicitly where it says like keep going on forever like this, or there's no exceptions to this or something like that. And that's not really how addition is programmed into the calculator.
Because that does sound to me like adding, you can always add. That's something that is taught to kids, that it always goes higher, it always goes up to 1. There is always a rule of continuation or continuation rule. And I would assume the same for the calculator, that even though it wasn't overtly programmed in the calculator, because the system doesn't have a stopping point. It's in
But it
programming. If you
does
don't,
have a
you know,
stopping point physically, like it can't add numbers higher than a certain value.
oh sure. So there we get an error message at a certain point, but we can know that if the programming of the system could continue going on binaries, it's like it's 1 1 0 1 0 1 1 1 whatever, and so we can continue the system indefinitely, and so it would follow the same rule as what we tell the kids. It just doesn't stop, even though we didn't overtly say it doesn't stop, because the pattern that's built into the program of the computer doesn't have a stopping point, and so by definition it wouldn't stop. And so it does seem to entail, by looking at the program in the calculator, that the system does continue indefinitely without stopping. There's no exception rule to tell it to stop. Therefore, that would overtly be a rule that it doesn't stop and continues forever, just like telling the kid that it doesn't. It just keeps going.
Well, so I mean, it seems to me like there's a little bit of a tension between the two things that you're saying. So on the one hand, what you're saying is if the thing is not built explicitly into it, then you're not doing quaddition. But on the other hand, you're saying it's okay that it's not explicitly built into it to do addition.
Well, no, I'm saying it is explicitly built into it to do addition. So in addition, every time you add one, it continues to go up forever without stopping, because there's no exception clause to stop it. Therefore, the pattern from the past will continue into the future indefinitely. And so if there's any change to that, you would need an exception clause. So in version 1, if there's no exception clause, you're doing the pattern, the system that has no changes. It just continues on.
Mhm.
And then for any version with an exception clause, you need to add the exception clause for it to be that system.
So you think the default is just regular addition? I mean, because the
Um,
way the calculators are programmed, again, is that they just take some finite, it's like a multiplications table. It's like there's no rule that's embodied by the multiplications table. You just look up the two numbers and you find there the number that's written there, and you write that down as the answer, which is the way people are taught multiplication at an early age, or addition as well. You're not taught some algorithm. You're taught, here's the answer: is 1 + 1 is 2, 1 + 2 is 3, and so forth. So you learn these things in that way. And there's some, like, you could think of an addition table that lists all the numbers and then the product, or the sum of the two, not the product. And that's what's built into the computer. It's a finite state automaton. So it's got only a finite set of states, and it doesn't have anything about continuing on after that. It's not as though, the axioms of arithmetic are built into calculators. It doesn't say for all x is a number, and the successor of n is n+1. It doesn't say anything like that inside the calculator.
Doesn't it? Because in most programming languages, what we write is just continuation, like 1 + 1 = n or whatever, and just press it and it just goes. It's not like, I don't think there's like a table for each of the individual numbers. It just, there's a table for like the first 10 and just continues adding them. So I think
Well,
like in
go
programming, we
ahead.
do
Yeah.
actually do the continuations of the numbers like that, where there's a system that it's supposed to follow. Like binaries is 0 0 1 0 1 1 1 0 0, and it just continues that pattern indefinitely until there's an exception rule, which we do include exception rules because we want it to stop before it breaks the computer. So we have exception rules that must be built in order to stop it from going down the system. And so I would say that addition, the continuation version, is the default, simply because it's the simplest version. It's the one that's you first program, and then you have to add an exception rule to make it be something different. And so if
Mhm.
we just have the continuation rule and we don't have any exception rules, then you're going to be doing the continuation language or meaning. And once you add an exception rule, then you're going to be doing the exception rule meaning. And if you don't add that exception rule, then even if you were attempting to program the computer to do quaddition, it won't be, because it doesn't have the exception rule. So it will be doing quaddition wrongly. And you could know that by looking at its programming, it seems like.
So how could you know whether it's doing quaddition or addition wrongly? Because you just said I think it's an important point that we do make mistakes, and if you allow that you can make a mistake and still be doing addition, then you could allow that you can make a mistake and still be doing quaddition. So this may, be a similar kind of case.
Well, so we look at the programming and say, does it have an exception rule? If it's not, doesn't have an exception rule, then it's going to continue on the standard rule indefinitely. And whatever we label the continuation version, that's the one that's doing correctly.
I mean, I still don't really see how you get out of the idea that the E might be the exception rule, that a clever designer might have made that an implementation of the exception rule.
Could you say that again? So that part I'm not understanding.
So the basic idea is that we take a system to be malfunctioning when it breaks or returns a value that we don't accept. But a clever designer might have made that as part of the design. So maybe the exception rule is, once you get up to quaddition, you just get the E. And that's built
Sure.
in.
Sure. So like we could say that we look at the programming of the calculator, and once it gets to a certain number, it shows an error message or something. And now it's doing the error addition. It's doing the error addition because after 2 billion, it just shows error message or whatever. And then you could say that the calculator is doing error addition because it's whatever it's adding up after a certain number, it shows error, and that would be fine. I would be happy to grant that the calculator is doing error addition.
Well, I meant
It's
that
not
it's
doing
doing
addition.
quaddition because instead of returning 5, it returns E, and E might simply be the designer's way of saying 5.
Well, sure. But I would say it's not doing addition. It's doing addition incorrectly. It's got addition incorrect because once you add 10 billion plus 1, you don't get E. You get 10 billion and 2. And so it's doing addition incorrectly, and it's doing quaddition correctly because it shows the E label after the number. And we can know that by looking at this program. We can show what it's going to do after it gets to a certain number. And so we can determine which meaning it has by looking at its programming either way.
Right, but you're assuming that you know what the E stands for in each case, which is what what the argument's challenging. So the designer might have made it so that the E signifies 5, so that whenever you quad two numbers, it returns the value for the same as addition up till 55 or 500 billion or whatever the number is, and then it returns E afterwards, and that's supposed to be your sign that it's 5.
Sure. Why would that be?
So, well, because
I-
the
yeah, go ahead.
calculator is compatible, it could be interpreted as doing either. So you can't just look at the program and read it off.
Is
There's an
doing
exception rule
either.
in there, and the exception rule, you're interpreting it in one way, and the court would interpret it another way. And the question is, what reason is there for one over the other?
So let me see if I can reframe that. So let's say there's a calculator, it goes to 10 or whatever, and then after 10, it starts using letters, but the letters could represent regular numbers, or they could represent a different, like the quaddition numbers or something.
Well, I'm just imagining the regular calculator, which you put in a big number and it returns E, and you're interpreting that as error. And the quad skeptic interprets that as 5.
Well, so the way I envision it is it's going to return an error after any number greater than whatever. And so you get the same message every time. And so it can't mean different things every time because that doesn't make any
Right,
sense
it just means
for it to
5.
mean, right. And so in that case, it's not, whatever it's doing, it's not doing addition because you know that in order to get, there's going to be different numbers for each iteration. You go higher than the specified number. And if it shows E for every one of those, it's doing addition wrong. Addition doesn't do that. And so we know it's not doing addition. It's doing a different variation. What variation it's doing, you may not know because the intention of what the E is supposed to mean, you may be unknown, and that's perfectly fine.
Wait, so
But
you
it's not
agree,
doing addition.
T-Jump, you agree that the regular calculators are not doing addition?
Yeah, absolutely, because they don't doing it correctly. Because they stop. They make mistakes. Calculators are dumb. They are not doing addition correctly. They're doing a simplified version. They're doing a Newtonian addition. They make simplified mistakes.
Uh-huh. So that's why, I can't really understand whether you are accepting the kind of skeptical conclusion or not, because that's sort of what the skeptic says. The skeptic says calculators are not adding, and most people say yes, they are. They're adding perfectly fine. It's just that there's a limitation on the storage in the device or something like that, so that it gives you, it can't add certain numbers after a higher value. But but they would certainly say they're adding 1 plus 1 and giving you 2. But it sounds like what you're saying is no, the calculator is not adding 1 plus 1.
Well, that seems like a separate issue because my main challenge is the question that you asked at the beginning. Is there something physically about the calculator that we can look at to know what rule it's following? My answer is yes. We can look at the programming. And then there's a separate issue of, well, are calculators doing addition? That, I would be happy to grant calculators aren't doing addition. Like, no, they're just simplified machines to do like the box system that you said. I don't care whether they're doing addition or not. But that question, I think, is not the one I'm interested in. I'm interested in the first question: is there something physically that we can look at a calculator, at a person, to know what meaning they intended? And I think the answer is yes. There has to be. It must necessarily be, barring quantum mechanical weirdness. There has to be, because I'm a determinist. Their brain is determined. Whatever they meant must be determined by their brain.
Yes. Everyone agrees, by the way. No one wants to be a skeptic. The whole thing is like, how do you get out of this puzzle? Even Kripke, as far as I understand, wasn't really convinced by this. And he said, well, there's got to be sort of what you're saying. There's got to be something which answers this question, but he could never figure out what it was, which is what the big puzzle is. So the question, is there something internal to you which answers the question, are you adding or quadding? So you say yes, and it's the programming. So the programming says here, so here's the programming. And you say, according to the programming of the calculator, it's not doing addition.
Sure.
Okay, so what is the difference between you and the calculator?
What is the difference between me?
Because you admit that the calculator is not adding, but why do you think you are?
Because I have been given the extra rule that it continues on indefinitely and doesn't stop. That is a rule that I've been taught.
Sorry, go ahead.
That's a rule that I've been taught it exists in my programming. So if we added that programming to the calculator, then it would be doing addition.
So that's, I don't know. So do you think of this as a skeptical answer? Like there's nothing about you all by yourself that determines this?
No, because I think there is. I think that there is in my brain the rule, it continues on forever. Because there is that rule, I am doing the addition. And if there was not that rule, then I would not be doing addition.
So you think explicitly represented in your brain somewhere is the rule, do this forever?
Yes, absolutely.
Interesting. Okay. So there's two parts to the challenge. One part is, can you say something that determines whether you're doing one thing or the other? The other thing is, does it justify you in giving your answer? So do you think that that's an important part of the challenge? Because I know you're a normative skeptic, so you might not even care about this stuff.
I'm not, that part I don't understand. I didn't understand what do you mean by justify? Because I'm just thinking justify true belief. Do you have some kind of something that increases the probability of the belief being true? Yeah, yes, I think so.
Do you think that
sure.
when you say, I know I was adding, that this rule thing that you say is written down in your brain is providing the answer to why you should say one thing versus the other?
If I could look into my brain and see the rule, like a list of rule sheets, and know that those were part of my brain, I would say yes. I say here I can see on the fMRI, it gives me a list of bullet points that are programmed in my brain. There it is. I'm justified in believing I'm doing addition.
So you think absent that you're not?
Yes, if I was unaware of the rules in my brain or what I was programmed to do, I would not be justified in concluding which one I was doing.
Okay. So you sounds like you basically agree with Kripke, because that's the conclusion of the argument, is that there's no way for you to do the thing that you're talking about. You can't look into your brain and see which rules are written there, absent the context, absent the community of which you're a part. But there's nothing inside which radiates addition in this way, independently of what the community expects of you.
I'd probably disagree with that because I think that anything the community teaches you is going to be physically determined by neurons in your brain, just like it's physically determined in a calculator. And so if you're doing
Yeah.
addition in your brain, that rule, that follow this rule infinitely, is actually physically somewhere in your brain that if we could read it, you would know. So I think there is something physically there that you could know about. And then the second question, would you be justified in it? I think, like, obviously I can't look into my brain and see that rule physically exists in there, but I have reasons to believe that it does. And so I would be justified in those reasons, which would then justify me in the position that I'm doing addition. So because of, I know how brains work, I know what an fMRI is, I know that beliefs are stored in the physical system in neurons. I'm then justified in believing that because I have been taught this and that was stored in my memory, I'm justified in believing I'm doing addition.
So, huh. Why not think the other thing that you're having some rule for quaddition in there and you've just never reached the number high enough where it'll kick in?
Because I have no evidence to justify that belief.
And well, sure you do. All the evidence for you doing addition is also evidence for you doing quaddition.
Well, so when I say evidence, I mean evidence of the exception rule. So I have evidence of the continue forever rule. That's something that's been taught to me. I have memories of this occurring. It could be false, like it could be in the Matrix, and I was actually taught quotation. I just don't know it. But I have no evidence of the exception rule anywhere in my past history. Therefore, I'm
Mhm.
not justified in believing I'm doing quaddition, whereas I am justified in believing I'm doing addition because I have the continuation rule. I have been taught the continuation rule.
And the continuation rule is do this forever.
Yes.
And forever means what?
Um, when you add one, it always goes another one up. And you can always
Well,
add
how do you
one.
know
And
that
that,
it doesn't mean add one and it goes another one up until 55?
because explicitly the rule is it continues on forever. That's explicitly the rule
Yes,
that
but
I've
the
been taught.
rule, but the word forever in the rule is compatible with this other meaning, namely that it goes on up to a certain point or else returns 55.
Well, I would say the same thing. I just have no evidence to support the conclusion that the word forever has an exception rule. The word forever, as far as I know, does not have the exception rule, and I've been taught that as well.
Well, in what way were you taught the word forever?
In what way was I taught the word forever?
Yes.
In grade school, um,
And what did they
they
tell
told
you?
me forever means continuing on without ever stopping or changing.
Uh-huh. And in the sentence, without ever stopping and changing, how do you know that the words stopping and changing don't have these alternative meanings? That you stop, well, that you go on up until a certain point and then don't.
Because
So
all
this
of
is
the
what that thing,
Yep.
yeah.
Because all of the explanatory analogies used are physical analogies that show a continuing pattern that does not ever change. And the point of those analogies is to differentiate changing versus non-changing, and they explicitly highlight the non-changing aspect into the definition of these words.
In what way?
Um, by using rocks, they say continuing rocks, and they say don't stop. So they say, well, what's the next thing? The next thing is a rock, to indicate that there is never a point where it changes to not be a rock. That is the intended explanation they are using. So whenever they say, well, what's the next thing? Is there a change? The answer is no. And by saying this pattern is the one we're going with, they explicitly bake into it that there is no change, and that is the meaning of the words. That's what they're conveying to the children. There isn't a
I mean,
change, and that is what we mean by the word forever.
so when we think about the word grew, it means green up until 2025 or blue afterwards. So if you wanted to find all the grew things, right now you would collect all the green things.
Sure.
Okay.
But
So, but go ahead. Yes.
if you were explaining what a green versus a blue thing is to a child, you'd say a green thing is a thing that is green and does not change to blue. And so at
Is
time
that
a
what they told you?
billion, what?
Who told you that?
Who told me that? I'm making this up right now. So I'm saying, like, if I am an elementary school teacher and I'm trying to teach a kid the difference between green and GRU, a green thing is something that will remain green forever. Time 8 billion gazillion, still green. And so if I'm explaining this to a kid and I want to try to explain what the foreverness of the green is, I'm going to say it does not change. There is no change. That's what a green thing is. No change ever under any circumstances does not change. And I'm going to explain this by comparing things that change and things that don't change. And I'm going to put this in the category of not changing things. And that's going how I'm going to explain all of these words to them. I'm going to intrinsically bake into the fact that the meaning of these words entails no change ever.
So you're a Platonist,
No.
but you just described Platonism. I mean, green
Wait,
things do
how?
change, and they're still green. So a faded green thing is still green, and an eaten
Sure.
green apple was a green apple, even though it has changed and is no longer green.
Sure. Well, so I'm trying to get to the definitions of forever and any analogous words. The definitions of those words are, they're not Platonic objects, but they're abstract objects. And those abstract objects entail a not change variable. The not change variable is programmed into people when they learn this word. It is a part of the meaning. And so we would know which system or which meaning they're using for these words because it's literally baked in. You must be doing this for it to be the meaning intended by these words. Does not change, not change. There's change and not change. This has to be in the not change version, or you're doing not the correct language. And so, in the same context of math, if there is a change variable, you have to program that change variable in independently in order for them to be doing the addition.
Hmm. I mean, I'm not really sure I understand. I see people are talking about how we look this early in the morning, by the way, in the chat. I don't know why they're interested in that, but thank you for noticing that I look so unhealthy at this early in the morning. So the question is, how do you know which of these you're doing? And what you're saying is, well, someone taught me that I'm doing this.
Well, that'll be the second stage. The first stage is it's determined in my brain physically which one I'm doing. So that part is it's physically determined which one I'm doing. And how am I justified in coming to that conclusion? Well, I have evidence. It may not be strong evidence. It's just something that increases the probability of the proposition being true or whatever. I have these memories of being taught this. Therefore, I have a justification in believing my brain is programmed in such and such way.
By the way, whoever's saying that I'm a narcissist is a weirdo, because I was talking to the person who said I look sick, not to them. So they seem like a narcissist to me. But anyway,
Well, how do you
how
know they
do
weren't talking about quarcists? They didn't mean quarcists.
yeah, I don't actually. I know. It's a good point. Um, so the question is, like, you say, do the same thing forever. And I say, gee, forever, that's a long time. Like forever, forever? And no one can do the same thing forever. Like that's literally impossible. So the rule, it sounds like you're building something into it, which is not physically possible, and which is still going to leave open these kinds of puzzles about what's going to happen after the physical system breaks down. Because you will die at some point, your brain will decompose. And we still want to say, well, gee, did you have a rule that said do it forever? Because you can't follow that rule.
Well, sure, we couldn't follow the rule, but is that relevant to the question? Because the question is,
Yes, the rule
is there
following
something?
argument.
Well, the
It's whether
question
you can follow the
is
rule
there?
is the whole question.
I don't think so. I think the question is there a way to determine which rule you're following? Whether or not you can follow it seems to be a different question. So, like, if there's a rule in my brain, suppose it's possible, brain says continue this pattern forever. If that rule exists, then we should have an answer to the question. It should be yes, there's the rule. And now you're bringing up a second question: is that rule possible to program? I would say yes. I'd say programming languages do that all the time. We program that in, even though computers can't do it. We program things in to computers they can't do all the time. But that doesn't mean there isn't a rule there. The rule is there, and we can know what the rule is by looking at the programming. Whether or not the computer has or will be able to ever get to the point where it executes on that rule doesn't seem relevant. Like it's that doesn't does that matter? I don't know. Um, But the relevant question is there a rule that can we know which rule they're following by looking at the program? The answer would be yes. I don't see the relevance of the part you're bringing up about whether or not it can actually accomplish the rule.
Well, because it has to do with whether that's what the rule states. So like when you say that the rule is written into the system in a certain way, you're assuming that you know what the words in the rule mean, and that the system is actually doing that as it unfolds, as its state transitions unfold. So
Well, I would
that
disagree there. I would disagree there because
okay.
in the analogy of the calculator, we're not looking at the words when we're looking at the program. We're looking at the physical system itself, the physical consequences of the dominoes and the ones and zeros. And so that's the part I'm saying is what's doing the determining, not the words. Like the words don't mean anything. It's what those words cause in the physical system or the physical representation of those words that's doing the determining. So we can look at the physical determined system, the way it's going to fall like dominoes, to know which system is, which rules are built into there. And we can build a series of dominoes that can represent continues on forever in a meaningful way. That would be my argument. And if that is possible, then there is a rule built into the calculator that we can find to know which one it's following.
So, I mean, I don't see. Okay, so you have the rule. The rule says, well, you say the rule determines a certain pattern of things, and then
Yeah.
you also say that rule determines that that pattern will like continue indefinitely. So
Yes.
where's that part of it? You said we're not looking at the words, we're looking at its consequences. The consequences are finite.
Well, no, not the consequence. So I'd say
So
there's two parts that are built into the physical system of the calculator. One is that there's a pattern, 1 + 1 = 2 or whatever, or 1 0 1 0 whatever. And then there's another part that is another physical system that says this pattern must not stop. And that is also there's some physical programming that is done in order to instantiate that rule, and both of those things are in the calculator, therefore we know it's doing addition. And then if it has the exception rule, we know it's doing quaddition. And if it has neither, then it's either going to do addition or the error version if it shows an error message or whatever. If it doesn't have an error message, it just breaks or something. But either way, we know which system the calculator is following by looking at the programming. And as a human, I think I have both of those rules built into my brain: the addition, follow the pattern, and then the it never stops. And both of those are physically determined parts of my neurology, which I can look at if I could look at them. And therefore,
mhm.
that answers the question. Is there a part of me that determines? The answer is yes.
So the part that says it never stops is contradictory with the actual performance of the machine because it does stop.
Sure.
So that
100%.
opens up the interpretation of that rule in lines with the quaddition. That namely, the never stop part is basically meaning up until a certain point and then stop. Because it does
So
stop. So you can't
sure.
say that it will go on forever because it doesn't. What you could say is there's something written down that says continue until it doesn't, until you get to the part where it breaks down. So that it's still the system is interpretable in either way.
Well, that's the part where at the beginning of the analogy I said is either determined by the brain or by the laws of physics. Now, obviously, the laws of physics are going to determine when the calculator breaks down. But it if it never broke down, we could say we could know what it's going to do by looking at the rules. And so
Granted, but we
either it's
can't.
mm,
So the whole idea of that someone clever enough who knew the laws of physics would know at what point this thing would break down and might have built that in so that it stops at the quaddition point. That might be exactly their intention.
well, that would be a part of the programming. That would be this thing we would know, and so we could then answer
Yes,
the
and it's
question.
exactly the same as the regular thing you're pointing out. So it's compatible with the never stop being written down in some way that it really means don't stop until you get to a certain number,
If
which
we
is what happens actually.
Yeah, if we include the biological death of the organism as a part of the programming, yes, absolutely. But that would still be a part of the programming, and we know which language it's using. So if we include that as a part of the programming, we know it's doing quaddition or whatever.
Exactly, but you don't know which one it's doing is the whole point. You don't know what the program is
I
because
still
the
think you
program,
do. So,
how
like
though?
in the case of the system of the brain operating, doing some intended goal of addition or whatever, it doesn't have the intended goal to stop at death. That is not. I'm not adding to know that. Well, when I die, that is where the just stops and goes to error message or whatever, and that
But
is
how do
not a
you know
rule that's
that?
been programmed into me because I wasn't taught that in elementary school. And so when
But it
I'm
might be
doing
a,
addition,
so do you, let me ask you this. Um, do you think that if you never went to elementary school, you wouldn't know what addition is?
possibly.
Okay. So you'd be mystified by 1 + 1 by having an object and another object and then saying there's two of them there. That would totally mystify you if you hadn't been
Well,
to
no,
elementary
I don't.
school.
I don't think I'd have a language or a system to describe those things. Probably.
But if you said ugh and chug is blug or whatever word you came up with, you don't think that these are kind of, you know, things that you might get outside of school?
Sure, I think animals can do some form of addition, something. Sure.
So okay, there you go. What is not really the point. The point is whether you're doing that function, whether you're implementing a certain
Yep.
function. There's a function called addition. There's another function called quaddition. In fact, there's infinite functions. Um, that you can just write them down, and that's perfectly fine. So how do you know that your biological death isn't part of the programming, which determines which function you're performing? That wasn't what you were taught in school,
Um,
sure, but the teachers might not know what they're saying.
let's see. How I don't know how to even try to answer that right now. Because that would entail that every organism would have a different system based off of its time of death, essentially. Um, doesn't make
Yes,
sense.
that's a huge, that's the skeptic. Exactly their point is that you can't, there's no facts that you can point to about anything that's in the brain, in the system at all, which makes it the case that you're doing addition versus quaddition versus smoddition versus anything that you want. So exactly the conclusion that you just said is supposed to be the conclusion of the argument.
I don't see the how that can be meaningfully translated as analogous to the programming, like based on what we mean by a program or rule or whatever. To say that the rule is contingent on the organism's lifespan is does not compute as a logical sentence to me.
Well, why not?
Um, because of what rules are seem to be some kind of a pattern that can be described within a system, and biological death of the organism does not seem to be such a thing that can be abstractly described in that way.
Why? I don't understand why you think that though, because a clever designer might be able to use all sorts of features of the system to implement a given function.
Sure, they could, but it seems like the use of the word rule would mean not that. So, like, when we say what rule are we following, the rule seems to refer to some kind of abstraction, like a set of principles or something. And your biological lifespan does not seem to be a rule in that sense.
Well, it might be part of the implementation of a rule. So the biological lifespan isn't itself a rule, but it might be the way that a clever designer chose to implement a certain rule.
'Cause
That
it seems
that
like
might,
it's arbitrary that there's no connection between doing audition or whatever system and your lifespan. It seems like there's completely arbitrary connection there. And so if we're asking,
Yeah, but there's a
which
completely arbitrary connection between addition and uh, uh, values of electricity in a register.
well,
There's a
I'd say that would
arbitrary
not be
relationship
arbitrary.
between. Whoa, really?
Yeah, yeah,
How
that's
so?
physically determined. I mean, that's not arbitrary. That's physically determined. We couldn't do that
We
any
can
way we
make it
wanted
any way
to.
we want. I mean, we
No, we
can.
cannot. We are not. There's physical limitations to what we can do with a calculator. That is physically determined by the laws of physics, and so it's not arbitrary. Um,
Well, but I mean, which values we assign to which electrical currents?
I think that's also physically determined. I don't think you can do that any way you want. I think it's literally physically determined. Um, whereas I don't
What do
see
you
that
mean
there's
by
any.
that? So you don't believe that computation and its implementation you can implement a computation any way that you want to? You don't think that you can
No,
implement a Turing machine using dominoes or using people holding mirrors or any of these standard ideas in computer science?
I don't think you get it to output anything you want it to.
I didn't say output anything you want to. I said you could implement the program in any way you want.
Uh,
So it's arbitrary what that we happen to use. I mean, old computers had vacuum tubes. These computers that we're talking through right now don't have vacuum tubes. It's totally arbitrary what the stuff inside is made of. What's important is whether it corresponds to this abstract function.
I am lost on trying to build this into the argument. The biological death is entailed in the program thing. I'm lost on how to build that into the argument.
Well, because the idea is that if you build a system, like I'm a programmer, so I want to program something into it, but I'm a very good designer. So what I do is I make it the case that this thing will implement a certain function by breaking down at a certain point.
Sure.
Okay, so I make it so that it implements the quaddition function by returning the values that would agree with addition up into some value n, and then breaking down at some point where the quaddition kicks in. And that's how I designed the system. It's not a deficit of the system that it breaks down or returns an error. It's not a deficit of the system that it dies or whatever. I built it into it because that's the way I want the function to be implemented.
So like I keep going back to thinking what I'm doing addition. I have some conscious intention of doing stuff, and then my biological death seems to be a completely separate, unrelated thing.
Of course, it seems to you
Um,
that way. You didn't design the system. The question is, how do you know? Like, what rules out that this isn't a part of the implementation of this other function? Like for a simple example, suppose that I have a security system on my door, and I want it to be the case that if you put the wrong code into the door, it won't open. But if you put the right code into the door, it short circuits and the lock opens. Now, that may be, according to you, a very inefficient way to implement this function, but it's still a way to do it, namely having the code open the door. So I just designed it so that putting that code in short circuits the system, thereby unlocking the door. If that's how I designed it, then that thing is performing correctly, this function of unlocking the door. So, I mean, that's just one simple way you could build malfunction in. I mean, I don't think that's very practical, but still, it could work.
sure.
So breaking down is compatible with implementing some function if you designed it the right way. Something that you might think is an error, you might say, oh, that thing's short circuited, it's not working right. But someone who designed it might say, yeah, that's exactly how I designed it. That's what it's supposed to do. And you would say, gee, that's weird. And they say, yeah, so. So that's the question is you would say, that's a very weird way to implement this function. And they would say, yeah, but it's still a way to do it.
Well, so because what I'm thinking is, so I've been programmed to think that addition goes on forever, and then I die, I'm not going on forever. But somehow there was a programmer who said it this way, so I couldn't go on forever. But I still have the
Yes.
program that goes on forever in my brain. So from my perspective,
Well,
um,
sorry, go ahead. Yeah.
when I've been taught the rules, if I wrote down all the rules, that's a system, and we can know what system that is. There's a system of rules. And there's this extra rule of me dying or something, and that would be in conflict with the first set of rules. So the first set of rules goes on forever without changing. And the second set of rules goes on until biological death or something.
Uh-huh.
And so from my perspective, it seems like which rule I'm following is still the one that's in my brain that I'm determined to write down the set of rules. If I write down the set of rules, this is the one I'm doing. And if there are other things that can interfere with those rules, that does not seem to be a part of the rules that I'm following, because it's not consciously verified set of what the rules I'm trying to do or whatever, the rules I've been taught. So I wouldn't be justified in believing those things. I would not be justified in believing I'm doing biological death quaddition or whatever. I would be justified in believing I'm doing addition because I can list this as here's the set of principles I'm doing, I'm following, and here's what they say, continues on forever. And so in that case, it seems like I can still answer the question of which rule have I been following. I'm following the one that the principles I write down, this is the set of rules I'm following. And those would be the ones I'd be justified in believing. And then the alternative biological quaddition ones would seem to be like back to the matrix argument. Like, could that be the case? Yes. Do I have any justification to believe that? No.
But I think you do have justification to believe it. And it's the same justification that you have for believing the other one, which is that you look at the rule, it's compatible with two interpretations. So one interpretation is go on forever in exactly the same way. The other interpretation is go on forever until Tuesday.
Well, so this is where I see this as the analogy to the matrix argument. Like, how is that different from saying I'm justified in believing we're in the matrix because everything I'm seeing around me is compatible with us being in the matrix?
That is your reason for being justified that you're in the matrix right now. In fact, I think you are justified for thinking that you're in the matrix.
So I would disagree. I'd say that justification comes with novel prediction. So I'd say predict something in the future. But because it seems like, so problem under determination, there's always infinitely many ways to explain all data, granted. But doesn't mean you're justified in believing any of those infinitely many ways. I'd say no. And so,
Well,
like, I
if you're
have
not
no
justified,
memory.
so sorry, go ahead. I don't mean to keep interrupting you.
That's not an issue. So like in the case of, I have memories of being taught mathematics in one way. So I'd be justified in believing that way. I have no memories of being taught quaddition, so I'm not justified in believing quaddition. So based on the experiences I've had, I'm justified in believing, what is that called? No defeaters thing. If there's no defeaters, I'm justified in believing it, whatever. I forget what that's called. But based on whatever system I start with, I'm justified in believing that system or what my intuitions initially hold, and not all of these alternatives, because
I mean, the
it's
skeptical
my
argument is
view.
supposed to be that you're not justified in believing any of them. So I'm not sure
Right.
why you can rule out all the other ones and just get to pick one. So like the matrix thing, whether you're in a
Phenomenal
simulation right
conservatism,
now.
phenomenal conservatism. Is that it?
Yeah, phenomenal conservatism. Yeah. But it's compatible with phenomenal conservatism that you've been doing quaddition your whole life. That's the point I've been trying to make.
Well, sure, but it's compatible that we're in the matrix as well. And
Exactly.
so that's why in our last conversation, I compared this to the matrix analogy. I don't see how this is any different from the matrix analogy, the matrix argument.
Well, I mean, I also think you don't know that you're not in the matrix. So I would be a skeptic also about whether you have that kind of knowledge. I mean, the skeptical claim here is that about what counts as meaning, that you can't know that you're in the matrix as well. I believe that there is no way to prove that you're not in the matrix. So you are justified in believing to some extent or other that you are in a simulation. And contrary to these very confident assertions in the chat, there is no way for you to know that you are in the matrix. Like how would you rule that out?
So like there's lots of arguments against matrix and solipsism. Like I have hands, whatever that argument is. I have hands.
You would have hands in the matrix as well.
Right. And so are you justified in believing you're not in the matrix? Sure. Based on this argument, both would be justified. But then you can make arguments like which one's simpler or something. And so based on simplicity, the not matrix argument is simpler, or the addition argument is simpler because it doesn't have an exception.
How is it
or whatever.
simpler?
Well, no exceptions. It's literally just, isn't that by definition simpler?
No, it's actually, I would say, much less simple to believe that you're not in the matrix right now, because the general argument, I mean, this is kind of switching topics now, but it's related. The general argument is that if there ever exists a time in the future where there are realistic simulated worlds, then any given creature with experience like ours is more likely to be in one of those as opposed to in the non-simulated world. So it would actually be like really, unsimple of you to assume that you're in the non-simulated world, because you have to assume that you're really lucky.
Well, so like in the addition one, the addition would be simpler than quaddition because quaddition entails a deviation of some kind. And so would you admit that addition would be the simpler version of than quaddition or whatever?
Yeah.
And so in the case of the biological death quaddition or whatever, that would be less simple. There's an extra rule there or something.
I
So
would
it seems
say
like
it's less simple, yes. I mean, each one has an extra rule. So in that way, not really, but in the sense that the extra rule in your case is just go on forever. And the extra rule in the quaddition case is like stop at some point and say 5. So they each have an extra rule. And I don't know if going on forever is simpler than stop and say 5. I don't know. They both have an amendment, so maybe they're not.
But yeah, so I see the conversation at two levels. One is like the pragmatic justification level, below the matrix level, and then there's the metaphysics level of are we at the matrix level? And when answering the question from the pragmatic level, I can look at the brain and say brain's programmed to do this. And based off of what the brain's programmed to do, you can tell what rule it is. And then you can say, well, maybe the biological programming of the brain to die at some point is entailed in the programming or something. But that seems so beyond, it's incomprehensible to me, I guess would be the right word. And because it's incomprehensible to me, I'm not justified in believing that that's justified. Whereas
I'm not sure why it's incomprehensible. I mean, you about the calculator that returned the E, you agreed that that could be a an indication that it was following some other program. In fact, you did say that. So the E error is similar to the biological, to breaking down in some way.
Well, to me, the breaking down is like the calculator is doing a thing, and then somebody comes along and just smashes it with a hammer. And like that's a part of the program. We're like, no, it literally is not part of the programming. That someone just smashed it with a hammer. That's totally different. And so that's why it's incomprehensible to me, because there's like,
yeah, we're not talking about smashing with a hammer. We're talking about breaking down, like according to like the physical laws. Like so, someone who designed the system wouldn't be able to predict that you came along and smashed it with a hammer, but they would be able to predict that after 25 years, this component would break down, or after 150,000 uses, this button would wear off or something like that, or after 60 to 75 years, you would die. Those things are different than smashing with a hammer. I'm not talking about running over with a car. I'm talking about biological, natural, malfunctioning in the way we would normally cause it. So I agree with you there that the hammer smashing isn't part of it. It's literally like the physical decomposition of the thing or
Well,
the
to me, that
returning
would
of the
be
error.
sure. Well, to me, that would be analogous to the hammer smashing. That's why it's incomprehensible to me, because including like the biological death of a person as a part of the programming would be like including the hammer smashing of the calculator as the programming of the calculator. And to me, that seems like a category, or there's like something that doesn't make sense there. That's why it's incomprehensible. It does not compute to try to include that as a part of the programming. It's not does not fit into what I mean by those words. And so when I look at the
Well, but you're just
programming
not a
of
good
a
programmer then. I mean,
possibly, but
so,
it's incomprehensible to me. I don't know. I don't. It does not make sense to me. And
but you
so
don't,
when I'm
what about
thinking
my lock analogy? You didn't buy that?
the lock analogy,
Yeah.
um, so trying to make a pattern in the lock analogy. What language was the lock using? Was the lock using? Um,
Suppose I have a keypad that controls the lock
yeah,
and I built it so that if you put the wrong code in, it beeps at you. But if you put the correct code in, it misfires and the lock opens.
yeah,
So there's where the destruction of the system is implementing the opening function.
yeah. So you could still
So
look
that
at
doesn't make sense to you?
that part makes sense. So yeah, we look at the programming of the keypad, and if you put in certain buttons, it opens, and if you put in the other ones, it doesn't open. So it seems like we could know what language it's using in the same way. Look at the programming.
Right. But the point is that the system breaking is part of it working correctly. So that does make sense,
All
is
right.
the
So
kind of
like
point.
in that one, you're doing the pattern, and then the pattern causes some kind of interaction, like it opens either by breaking or not breaking. And so if that fit into like the biological death, if counting to a certain number causes everyone to die or something, maybe that would fit the analogy, I
It
guess.
does. It does. I mean, start counting now, and then when you die, there's the number.
Well,
Counting, you will never be able. It's just that's the way it works.
that part that's the part that doesn't seem to make sense to me. That's like, well, eventually the keypad is going to decay or rust or whatever, and that would including that as a part of the programming, it seems to be analogous to the hammer smashing. Like that does not compute to me. So it seems like there's layers to what we mean by programming there. One is the physical constituents of the printed circuit board, and the other is the external stuff that's not on the printed circuit board. And
Right.
so when I'm talking about programming, I want to limit it to the some kind of, I don't know, governing system within the object, the PCB or the brain, and only the the principles or the whatever bullet point principles of what it's trying to accomplish count as programming. Its physical limitations in the world don't seem to count as programming to me. Um,
But
and I don't see
the
why that would
physical
be unjustified.
limitations aren't programming. The question is, could a clever designer who knew about the physical limitations use those physical limitations as a way of implementing the program?
Sure, but the question
And the
is, would I
answer
be?
seems obviously yes.
Yeah, yeah, absolutely. But the question would be: is am I justified in believing that I'm doing addition, even though I don't, even though that's possible? I was like, yes. It still seems like I can rationally conclude that my brain is doing addition because I have these set of principles, one of which is continue on forever, even though knowing my brain's going to die, and even though knowing the Christian God could have designed it this way because he wanted me to do quaddition or whatever, I still think I'm justified in believing I'm doing addition, not because I don't think that those aspects would be normally considered to be a part of the rule following. That doesn't, to me, that seems
Well, first of all, there's
incomprehensible.
two things. Remember, the one is there something that is the rule? The other is, can you follow that rule? So we've been all this time mostly talking about just that first thing. Is there something which you could identify as the rule?
Sure.
And that's what I've been challenging this whole time. What I've been saying is that anything that you put out as a candidate as being the rule, which is implemented in the system, there will be another interpretation of that, which is in line with the skeptics. And that therefore, it really is true that Kripke's claim that the entire past history is compatible with either rule being followed. So you keep trying to rule out that it's the past history is compatible with this other rule being followed. And that's what I'm challenging. I'm challenging the idea that your past history makes it the case that you've only been doing adding. Because the whole argument starts with the questioning of that and saying, well, no, in fact, you were wrong. The entire time in the past when you thought you were giving the right answers in your school, you're giving the wrong answers. And you say, no, I wasn't. I was doing addition. And I say, how do you know? And then you say, okay, well, because there's something in there that says go on forever. And then you just reinterpret that and say, well, go on forever or stop on Tuesday or go on until the system breaks down, etc.
Well, that's the part that I think is
So
incoherent because those are contradictory things. Those two rules contradict one another. And so if we're trying to
in
determine
what
which
way?
one, well, if one says go on forever and one says go on forever until you die, that's not going on forever. So those are
Well, it
literally
depends on what forever
contradictions.
means.
Well, sure. So if we take the general understood meaning of the words, they would be a contradiction. And
Yeah, but the
so
whole
if I'm
question is
trying
whether you
to,
can have that.
well, yes, but so here's the part where I'm getting stuck. I'm trying to determine when I'm saying I'm following a rule, what are the things we are allowed to say are built as a part of that rule? And if there was some crazy designer who did this, we should be able to look at all of the physical parts of the universe to know the programming of the universe, and we could still answer that question. Um, just like we could for a smaller system of a calculator. We could know for the calculator what it's doing if we're only looking at the things inside the calculator, ignoring its physical heat death, we could know what it's doing. And then if we could include its heat death or breaking down, we could know what it's doing. And if we could include the universe, we could know what it's doing. In all of the cases, if we could look at the programming, we could know what it's doing.
Right,
And
but in the calculator, you admitted, I thought that's not the case
for which thing?
for the calculator.
For the calculator. So if we look at the calculator and we know what's been, if it has the rules of go on forever, we know it's doing addition, even if it can't go on forever. So its physical limitations of it being unable to do so seem irrelevant, but it has that program in it, go on forever, it's doing addition. And then we look at, can it go on after addition? No, it can't. It's going to physically break down. And now if we
Right.
include that as a part of the rules, we're looking at it's doing quaddition or whatever. That's the part that doesn't make sense to me. But we could still look at all of the system. We could still know what it's doing by looking at all of the rules of the system in that case. It would still be a determining factor of which one it's doing. It's doing quaddition because it's part of its programming is it's going to break. So it's doing quaddition. And so either way, if we look at the physical programming of the system, we can know which one it's doing. And so my position would still be the same, that we could know what it's doing by looking at the programming.
Right, but you'd
And
have
so
to
like,
then know which program I was implementing, and you can't know that by looking at what it does.
right.
So,
You can't
I
look.
agree that if you knew the program, then the puzzle would be solved. The whole puzzle is how do you know which program it's following?
All right. So the first thing I agree with the part that we can't know which program it's doing just by looking at the output. That part I agree with. That one's easy.
Okay.
The part I disagree with is the part where there's nothing about the system that you could know which program it's doing. That's the part I disagree with. I think that the program is there. The program is by definition in the system. So there is something about the system that we can look at to know which program it's using.
Well, that's question begging. So it's not clear that the program is there. What's there is some stuff internal to it that makes it act in a certain way. And then you want to interpret that in one way, and the skeptic wants to interpret it in a different way. And the question is, what reason is there for interpreting it one way versus the other? So you can't just start with, we know what the program is. The question is, what is the program? What is it doing?
Well, that seems to be the second part of the argument. The first part of the argument is there anything about the object that we can know which rule it's following? And the second one is, how can we know that thing, whatever it is? First part, it has physical limitations. So we know from its physical limitations what it's going to do. And then if you include its physical death or something, that to me it seems incomprehensible to the question. But you can, and you'd still know which language it's using. So if you include that in, you know which one it's doing. It's doing quotition because it's the death
But
quotition or
how?
whatever. Well, if you take the programming in this case is including the death and the switches inside or whatever, then you know it's doing death quaddition or something, because that's the programming. The programming is just all of those things. If you include death in the programming, you know the programming, you know which one it's doing.
So how do you know which program the system is implementing? That's the quite. I don't understand how you claim to know.
So if we're saying whatever things constitute the programming, whether it's just the PCB or the PCB plus physical death, we can know
What's PCB, by the way? I must have missed that.
printed circuit board, like just the binary ones and zeros.
Oh, okay. Yeah. Sorry. Yeah.
So I'm just including the PCB stuff. If we just look at the PCB stuff, it's doing addition. If we're looking
Wait,
at the
hold on.
PCB plus,
Hold on. How do you get that?
because it's in the programming that this continues on forever. It's one of the rules that's been in
Where
the
in the
PCB.
circuit board does it say forever?
There's a specific way to write that in binary. I don't know enough. There is an answer to that question in programming that they can do that literally says continues on forever.
But how do you know that that thing which is written down in binary doesn't mean continue like this until Tuesday?
Because it's not physically, the physical system makes it go on forever.
But it doesn't, because it will break down at some point. So it does not go on forever. It might break down on a Tuesday, let's say.
So like, how would I phrase this? It's if the system never broke down, the way that the orientation of these ones and zeros is set is so that this pattern will not stop. It's literally programmed do not stop. It's one of the principles that's built into this physical system. So it will continue on forever. That's the point of the program.
But how do you know that? You keep saying that, but I don't know how you know that. Because somebody intended to make it that way?
No, it's like physically the system does just works that way. It's like how the orientation of the ones and zeros and the switches are set is such that it will not stop. It's like a circle. When will the circle stop? When will the electricity stop going in a circle? And it won't. It won't stop going. It won't. You get enough, just keep going.
But it will stop. And it does stop.
Well, so it can stop for reasons like internal to the PCB, like the switches, or it can stop for reasons external to the PCB, like heat death or volcanoes or whatever, they're hammers. And so if we're looking at the programming, I would say the only relevant factors are the ones inside the PCB. What are the switches telling it to do? And saying that there's some external switch like a hammer or physical death or whatever, I think I would not count that as a part of the programming. I would say that's not rationally considered part of the programming. So if we look at the PCB and just look at the switches, we know what it's going to do. We know which language is following. And then if we include the external stuff, we also know what language is following. It's going to be the other one. And so you can either way know which language is following by looking at the programming. It's just what parts you count as the programming. The PCB, which is what I would only rationally count that, or this extra stuff of the biological death or death of the object.
Right. So why do you get to only count one as opposed to the other?
So to me, it seems like the word, what we're asking is, when we ask, is there something within the object that determines what it's doing? We're looking at the things within the objects, not the externalities to the object, which would be its death. I would put that in one of the externalities of the object. So if we're saying what rules are the object following, the way I interpret that statement would mean only things rationally limited to the internal functioning of it, not the externalities.
But that might be So first of all, this is not the halting problem, as people keep for some reason confusing the two things. They are completely different. So the question here is, how do you know what those ones and zeros really mean? What do they mean? So there's ones and zeros there, everyone knows. But what do they mean? You interpret them as one way. The skeptic interprets them in another way. Now, it's not the halting problem. People are very confused about this. So how do you get to pick? So you're saying within the community of people called pro, they mean this. So that's the skeptical solution. Within the community, we expect one thing and not the other. But absent that, and appealing to the person who intended to put a certain program into the system and have it do a certain thing, how do you solve that problem?
Well, so I'm
Because no
ignoring the
one knows
programmers.
who
I'm just
designed your brain, so we can't ask them.
right. So I'm ignoring the programmers. I don't care what the programmers intended. They don't matter to me. All I care about is the physical system of the PCB, the printed circuit board. If you have a circle where the electricity goes in a circle and there's no off route, all little like a stop, which is what a stop would be, is like where the electricity leaves the circle and it stops the system. If it's just a circle and there's no off route, it's continue forever, because that's just what the circle means. It's physically the physical consequences of the circle with no off route for the electricity. If it has an off route, you're doing off route quaddition. If it has no off route, you're doing no off route addition. And so we can say, by looking at the physical system, if there is a exception clause, which is the off route, and if there's no exception clause, there's no off route. And then you're including this externality as an off route, as an alternative off route, or it just breaks or something.
Yes.
To me, that seems to be outside of the bounds of the question, because the question is what is there anything inside of this object, about this object, that we could know what rule it's following? And if we look at the orientation of the electrical electrodes in the PCB, it's doing this one. We can answer the question. Now, for it to be doing a different one, you have to look outside of those things to a different thing. So we know that the PCB is following rule addition. And then if you include PCB plus physics destroys it, then only then can you say it could be doing quaddition. But if you're just looking at the PCB in the way the electricity works, there's only one interpretation. It has a circle, it has no off route, it's doing addition.
Right. I mean, so you gave Kripke's argument. Exactly. So you can't pick between the two. Everything in the system's history is compatible with both. So if you define it in one way, then it is doing it. If you define it in a different way, then it isn't doing it. What's the right way to define it? There's two ways. Arbitrarily saying this is the definition I prefer doesn't, I mean, it just says, yeah, I don't, I pick this one, but it doesn't tell you why you get to pick that one, or how it is that you're justified in assuming that you should be going on forever, or anything like that. It doesn't really answer the question. It just says, so you can stipulate, yeah, and I think that's the way we do programming. We stipulate that what we mean. That's why calculators count as doing addition, because the designer intended for that to be capturing some part of addition. But if the designer had intended something different, then it would be not doing that, it'd be doing quaddition. So it comes down to who built it and what do they have in mind. You can't just look at the circuit board and know.
That's the part that still just is incomprehensible to me, because to me, like, if we're asking the question, is there something within the object to know what language it's following? That seems like that question is only relevant to the things the object has control over. It does not have control over its depth. It doesn't have control. It has control over the little switches inside. It can change the switches whenever it wants. And so when we're asking what language is that following, we're only asking about the switches. We're not asking about any of the other things it doesn't have control over. It's death, volcanoes.
We're
hammers.
asking about the designer. I mean, the thing has to
Well, no,
be
I don't
built,
think
right?
so. I don't.
Yeah.
I think the designer is irrelevant. I couldn't care less about the designer. I want to know what the physical consequences of the object are. And so whether the designer intended it, I couldn't care less. So when I'm asking the question, what rule is the object following? I'm asking what are the physical results of what it's doing. I couldn't care less about the designer. That
Right. But
doesn't
that's the
seem.
problem, is that the physical results that it's doing are compatible with these two different interpretations.
That's the part I disagree with. So if we're looking at the PCB, just the parts that it can control, it's only compatible with addition because it has a circle. There's no off switch. There's no exit ramp. There's no exception clause. It's only once you leave this and add the other stuff, which I don't think is a part of the question, that you can get the quaddition.
Well,
So
it
if
is
you're
part of
looking
the
at,
question, because the question is, how do you know that you get to leave that stuff off?
to me, that's like in the definition of what rule is this object following. That seems to imply that it's only the things under which the object is in control of. Like to say that
But
I'm
why? I mean, that's
because
part I
it's
don't
like
understand.
the hammer thing. You granted that someone coming by and smashing it with a hammer isn't a part of the rule it's following. And
Right.
so if there's an externality, a thing it has no control over, to which it causes a different pattern, the object wasn't following this alternative pattern. The object plus the externality, you could say, was following this alternative pattern, but the object was not following this external pattern. And so when we look at the object, we know it's doing addition. But then if we look at the object plus the externality, that system could be doing quaddition, and that system could have been designed by designer Bob or whatever. But the object was doing addition. It was doing addition correctly. And then the externality came in and smashed it. And so to me, the answer is either way, we can know which system it's following. The object is doing addition. The object plus the hammer is doing quaddition. And maybe that system was designed by Bob, but I don't care because either way, we can still know what languages or what rule it's following by looking at the programming.
Suppose I'm an alien from Alpha Centauri, and I build this device, and the device is a calculator for quaddition, and that's what I intend for it to do. And what I want this thing to do is to add numbers up to 100,000 and then return an E to signify that the quaddition result, because it's always 5. So you don't really have to have it say 5. You could just know that, okay, so this is in the 5 domain. So I build it that way, intending that this is what it's supposed to be doing. I then ship it to Earth, and you find it. And you say, this thing is adding. And I come to Earth and say, no, I'm wrong.
Wait, was say that again. You're wrong.
Yeah, am I wrong? Because it doesn't seem like I am.
I being the person with the calculator, or I being the alien from Alpha Centauri. Who are you
So
talking about?
suppose I ship the calculator, I address it to Tom Jump, care of Church of the Everlasting Help Everyone. What is your church again? I forget.
Church
The
of the
Best
Best
Possible
Possible
World.
Worlds.
Yes, exactly. The Best Possible World is one where they do addition, obviously. So I ship it to you. You open it up. You look at this calculator and you start putting numbers in it, and you get all the numbers you expect, except for at some point it returns an E. Then you say, this thing is doing addition. I looked inside of it. I see what it's doing. And then I, the alien, come to Earth. And I come to your house. And I say, did you get my quaddition present? And you say, what? No, this is doing addition. And then I explain to you how I designed it. Am I incorrect?
So I would say if we look at the programming, we could tell who is correct and who is not correct. So like if it's quaddition, then at some point it will change to the exception clause, which would be the E. So yes, you're right. You're doing it's doing quaddition. If there is no exception clause and the object just breaks, I would say I'm right. It's doing addition. And so there's an externality there that is outside of the object. So we're asking about the object itself. What is the object doing? If the object was programmed to just send an E back, and the object is doing quaddition. If the object does math and then breaks, I'd say it's doing addition, not quaddition. So if it's internal to the object, what is the object doing? The object is doing what its programming is telling it to do. And if it's give back E, it's doing quaddition. If it just keeps going till it breaks, I'd say it's doing addition.
Okay. So you agree, though, that the intention of the designer matters.
No. I'd say
Well, suppose
only.
I'm a different alien now, and I built the same device, but I intended it to do addition. And then I come to Earth and tell you, I designed this to do addition, but large numbers, no one ever gets that high, so I just didn't program that part in.
I'd
You
say
say I'm wrong?
it's doing quad. Yes, I'd say you're wrong. It's doing quaddition. You programmed it in such a way that after a certain large number, it returns an error value. It's doing quaddition. And if you programmed it to just keep going till it breaks, I'd say it is doing addition, correctly doing addition.
Okay, so that's a strange way. I mean, I'm surprised by that result, but okay. So uh, I, the designer, could be wrong about the thing I designed, what function is
Absolutely. That
implementing.
happens all the time. Happens all the time.
Okay, so our current designers could be wrong about what function they're implementing.
Sure.
Okay, so then there's no way to know.
Well, I'd say by what if you look at the program and calculate the consequences, you know what it's doing. So I don't, whether the designer intended it that way or not, I don't think it's ever relevant. I don't think it's ever relevant what the designer intended. I think that the programming of the object and the consequences that will entail will tell you what it's doing every time, always.
Interesting. So you don't think that there's any, so the alien from Alpha and Centauri just couldn't build a system that worked in the way that I'm talking about, according to you?
No, I think
Like
you could.
I
So I think
just,
you could build a system that does quaddition where it has an exception clause that once it gets to this point, do E. And then that would be
but
doing
what about
quaddition,
if
just
the
like
exception clause is once it gets to this point, short circuit?
that's the part I don't think that would not count. That part would be it's doing addition. And when it breaks, that's the externality. So I think when you have the externalities, you're not asking what is the object doing. You're asking what is the object plus the externality doing. It's a different system. So if the original question is there something within the object to know which system it's doing? The answer is what the PCB is printed to do. And if there's and so we answer the question yes. And then if you're asking what is the object plus the externality, that's a different question. You can still get the same answer. Yes, you just look at the programming which of the whole system. But that's different than asking about the object in and of itself, because you're asking about the object plus this externality of the breaking. And so for me, I would still say yes, we can look at the programming, and even if we include this externality thing, you could still look at the programming. It's just whether or not it's a part of the object, as in it's not a part of how it was designed. I mean, literally a physical part of the functioning object versus external to the functioning object.
What counts as external? Something that's not on the PCB.
Yeah, something that the PCB doesn't control.
Uh-huh. In what sense of control are we invoking here?
So like when I control my thoughts or whatever, I don't have control over my aging process. It's not something I can manipulate, turn on and off repeatedly whenever I want.
Mm-hmm.
So I would say control is that thing, things that it can change back and forth whenever it wants, kind of a thing.
So flipping the zeros to ones and ones to zeros.
Yes. But
Okay.
breaking implies that you can't change it back. It means
Right.
it's done. And so then that's outside of your control. You've lost control over this function. You're broken. And so I would say things you can control are things that are manipulatable, manual manipulation. Broken is things you can't control. You've lost control.
And you just think for some reason it's impossible to use those. I mean, the basic idea, which I'm trying to press you on, is that we harness elements of the physical world in order to make them compute. Electrons don't compute on their own. States of electricity don't compute on their own. We harness those features of the world. We don't
Depends
even
which
need.
philosopher you ask.
Oh yeah, which ones should I ask that would deny this?
The computability things, that just everything is computation. I'm sure I've read that somewhere.
Oh, I see what you mean. Well, I was talking about things we make. Yeah. So if
Yeah,
the laws of physics are implementing computations, and they still are harnessing physical things to implement computations, you would say. And it's conceivable that those could have been implemented in different ways. So that's good. But the stuff that we build harnesses stuff that we find already that's out there. And then we arrange it in certain ways so that it mirrors or abstractly relates to this, state transition space that we're interested in. So which things we use seems completely arbitrary. This is the point I was trying to make earlier. It seems like anything that's out there in the external world can be harnessed in a way to perform computations. Like which things out there aren't that way? Well, so far as we can tell, there aren't any. Turing machines can be implemented by any kind of system, physical or otherwise. The only thing that matters, well, maybe, real Turing machines can't because they specify infinite tape and nothing like that is real. So I don't know, there might be some issues here. But any sort of system that's built by us harnesses some physical thing and then makes it behave in a certain way as according to the way the computation is supposed to go. Right? You agree with that?
Yep.
Okay. So why are you then limiting yourself to some arbitrary subset of the things that we can harness, which are whatever controllable things are inside of the system? It seems like a clever designer could harness any physical property. That's the kind of point. Even ones that we think of as anomalous or malfunctioning could be harnessed by a clever enough designer. So you seem to be arbitrarily ruling that out.
No, so I agree with that. But if we're asking, the question is there anything in the object? So it depends what we classify as the object. So if we classify the object as the internal structure of the PCB, it's doing addition. Now, the designer could have included this externality of a physical decay or whatever, but that would be a different system. We're not asking about the object of the PCB. We're asking about the object of the PCB plus externality. Either way, you can still answer the question. You can still know which system it's doing by looking at the programming. So if we include the death of the PCB or the death of the biological unit, that system, we can know which one it's doing by looking at the programming. It's doing quaddition because it's going to die or whatever. And so either way, we answer the question yes. And so from, like, if you were saying which one is right, which one is the correct interpretation, they're both correct. They're both correct interpretations because the object refers to either the singular PCB or the PCB plus the externality. And so either way, we can know which system it's following. And either way, the answer is only correct for one of them based off of which system you're looking at, the individual or the collective. And now, if you want to ask a meta question, is which one is the preferred interpretation? I don't think that part is relevant. I don't think that part is meaningful because it's correct either way. Like the PCB is doing addition, the PCB plus the hammer is doing quaddition. Those statements are both correct.
Right. So how come you haven't just admitted that the skeptic is right? Because the question is there anything that you could look at the internal states of the system, which would distinguish between these two things? And you just said no. Because the whole question is about what's inside your head. And there are these two different programs, one which is involving these externalities, which you're ruling out, and the other one which doesn't. And both of them are compatible with every state inside the system.
I think that's the part I'm disagreeing with because inside the system seems to refer to just the internal components of the PCB and not the externalities. That seems to be
Yes,
a
that's right.
requirement.
Yeah.
And if we don't include the externality, we can look at the PCB and say, this is the one it's doing.
Why?
Because the
Doing
physical,
that, so remember, there's two options. One is it's designed to do this and it accidentally breaks down at some point in the future. The other interpretation is it's designed to do this and break down at some point in the future. So on one interpretation, you have all the internal states plus an accidental malfunction. And on the other interpretation, you have all of the internal states plus a designed malfunction. And so the question is, which one? So looking at the internal states doesn't tell you.
well, to me, they're both the same. They're both doing addition either way. The
Yeah, but
breakdown,
That's weird.
the breakdown seems to be an externality that's outside of the system. So if we're asking the question, if we look in the system, can we determine which program it's doing? In the system seems to be incompatible with it breaking down, because that's the control thing I mentioned earlier. Like in the system is only the things it controls. If it breaks down, it no longer has control, so it's not in the system. That would be my intuitive understanding of in the system, what we mean by in the system. And so breaks down seems to be incompatible with in the system.
Right, it is. The point, though, is that all the stuff in the system is compatible with these two different programs. One where the externality is a malfunction, and the other where the externality is not a malfunction. The stuff the system is doing doesn't tell you which of those two interpretations is right. That's the
Well, to me, it
challenge.
seems in both the system is doing addition. Both of them, the system is doing addition. There is no quaddition. When it breaks down, the system has lost control. It's doing nothing. So in both, it is 100% doing addition all the way up until it breaks, and then it's doing nothing in both cases.
But I, the
But I think we
designer,
can.
say I designed it to break down at exactly this point. I mean,
Well,
that's like you saying that my key lock thing wasn't designed to open the door. I did design it that way. I designed it to short circuit and therefore open the door. Or alternatively, I could have designed it so that the door only opens after the keys on the keypad wear down enough. And you would say, gee, that's weird, but that's how I designed it. So the code is really just the right password is wait, punch all the numbers until the key codes wore down. That could be something that I built the system to do.
so again, from my perspective, I don't think the designer has any relevance at all. I don't think they have any say. I think it's all the
Yeah,
physical.
but the argument is supposed to be exactly for the claim that the designer has all the say. That's the whole point. So, I mean, you can't just look at the system and say, absent the intention of the designer, what it's doing.
Why not?
Because it's compatible with the designer intending that this thing work like this and then it broke accidentally, and also compatible with the designer intending that it work like this and break down at a certain point as a way of doing what it wants. So in both cases, you have the same thing. You have the system doing stuff until it breaks down. And in one case, that was an accident. We say it malfunctioned. And in the other case, we say that's exactly what it was supposed to do. And the internal states of the systems are the same.
So I would say in both cases, it's just that is one rule. There is only one rule, and that is it goes until it breaks down or whatever. And there is no intention of the designer making it into a separate possible rule there. So I'd say
But
that
then you're
whatever
just
the
saying that I
physical.
can't build a device like this, which I mean, I could. I mean, if I, why couldn't I build a device like this?
Well, sure, you could build a device like that. I don't whether you could build it is separate from what is the rule that it's following. So you could build a device with whatever intention you wanted, but the rule that the object is following is going to be determined by its physical consequences of what happens to it or whatever. And
Exactly,
so,
and it breaks down at a certain point, which is one of the physical
sure,
consequences.
sure, but there's only one rule there. In both cases, the only option rule is object goes until it breaks down or something. What you intended for it, whether you intended it to be a habit or not, or whether you intended it to not break down, makes no difference. Your intentions are completely irrelevant. The rule the object is following, it goes until it breaks down. Um, and so I think no matter what the rule is, you can know what rule it's following by saying the physical consequences of what happens to the object. And I think that'll always answer the question, what rule is it following?
Right, but why isn't that just begging the question? Because if I am the designer and I build this system to implement a certain rule by breaking down, then that's how I built it, and it's working correctly when it does that. And you're saying, no, it's not, and that I'm wrong. I can't build a system like that because it would be some other function, which I didn't intend, even though I know all the details about how it functions, when it's going to break down, and I use that as a part of my design.
I would say that the laws of physics essentially are the ultimate determinant of the rule, and your intended rules are irrelevant. So the reason you can't have a different rule is whatever the physical consequences of the system are, that's the rule. And you can describe it in a different way if you want, but the rule is the physical consequences of the system. And so,
But these are physical consequences of the system, and I know that as a designer.
sure.
So in my lock case, if I build it so that you put down, it was to put in the correct code and it malfunctions, then it's not malfunctioning. It's doing exactly what it's supposed to do. So someone who came along and said, this lock is broken, would be wrong. They just would be mistaken. That's exactly how I built it. They would say, gee, this lock is weird. You put in a code and it's short circuited. It's broken. It just accidentally opened the door. And then I would come along and say, no, I built it that way. That's what I wanted it to do. So it seems like you can't say I'm wrong about that. That's how I built it.
Right, right. So that's fine. But if you're saying, is the lock following a rule or whatever, and we look at the lock, its internal functioning, does its internal functioning follow this rule? The answer would be no. It's only the internal functioning plus this physical limitation that causes it to break that's following this rule. So that would be the externality. So is the lock
Right.
following this rule? No. Is the lock plus the breaking following the rule? Yes. Either way, we can look at the system and know which rule it's following by the physical consequences of the system. And so
I mean,
I can say you
yeah,
designed the lock plus the breaking to function in this way. Happy to grant that. Is the lock following the rule? No. The lock plus the breaking is following the rule. Um, and so either way, it still seems like we can look at the system and look at the programming to know what it's doing.
but
And
you would be
then,
wrong if you just looked at the program. The question is what the word, is it breaking down? Is that really the correct description of the system? Um, and you can't know that without knowing how I designed it.
well, again, I would say breaking down is whether it loses control over something. If it loses control over something, it's broken.
Yeah, but if I designed it, it didn't lose control. It did what it's supposed to do.
Well, it still can't undo it, so it'd still be broken in that context.
A lock that works just one, a function that's performed one time is still a good performance of that function. I mean, so if you set up dominoes and they knock them over, that just happened one time. Maybe you can't repeat it, but at that point you can't come along and say, oh, that's not what it's supposed to do or something. The question is it doing what it's supposed to do? And in this case, the answer is yes, because I built it that way.
The supposed to do part I'm not following, because if we want to know what rule it's following, who cares what it's supposed to do, which was what it's
Well,
going to
that's,
do.
oh, yeah. So saying what rule it's following is bound up with saying what it's supposed to be doing. Is it malfunctioning or is it functioning correctly? That's why
Why
I
would
asked
those be
about that
bound
norm.
up?
Well, because in the two cases, in the one case, you say, this thing is performing function X and it is not working correctly at this time T. And in the other case, you're saying, this system is performing function Y by correctly breaking down at time T. So the whole question is whether it's a design, it's functioning as it's supposed to when it's doing what you call malfunctioning. Because the clever designer isn't, it's not a malfunction. It's doing exactly what it was designed to do. It's working it correctly by breaking down. You would, by doing something that you would consider to be breaking down. So that's the question is it functioning correctly? Is it doing what it's supposed to be doing? And you look at it and go, no, it's totally broken. And I look at it and go, no, it's doing exactly what it's supposed to be doing.
So the meaning part, when you ask which rule the object is following,
Yeah.
why can't we say object A on its own, the prior to the breaking is following one rule, and then when it's broken, it's following a different rule?
Well, because if I, the designer, would come along and say, you're incorrect. I designed it to be following this rule, which is, work like this until the correct code is put in and then malfunction. I mean, quote, quote, malfunction. It's not really malfunctioning, but, short circuit or whatever. Take advantage of some physical property that the system has, which I'm clever enough to exploit. The point that I was trying to raise earlier is that all of this stuff that we use to compute are just exploiting physical things in the environment. Malfunctioning is a thing in the environment which we could exploit to implement functions.
Um,
So that the past behavior of the system is compatible with either of these interpretations. And there's nothing inside the system you could point to which would tell you which one was correct, which you seem to already admit. You said if you just look at the system itself, you don't know whether it's doing this correctly or that incorrectly, which is the whole skeptical challenge. Were you in the past adding correctly, or were you in the past using quaddition incorrectly when you gave certain answers to certain questions? So the whole question has been, is the system working right, or is the system not working right?
right. And I'm still on the perspective of who gets to define what's right. So, like, if the system is trying to do something, like if I'm trying to add and I add 1 + 1 = 2 or whatever, and I have no exclusion clause, I'm doing addition. It seems like that question is solved. Like, the one who determines whether or not you're doing addition correctly is you. Your brain. What are the principles in your brain? You determine that. No one else gets to say. And
Yeah,
for an object, I would say the same thing is true. The object, how it functions without breaking, is the same as you doing addition with your principles. When you're breaking, it seems like you're not doing the rule anymore, because when you're trying to do the rule, you're trying to do the whatever your brain is programmed to do without breaking. If you're breaking,
yeah.
you're not doing the rule. So to me, it seems like how we would determine who is correct is based off of the object itself and the things within the object without it breaking. And that determines the correct answer. The adding the breaking part seems to be incorrect. Seems to be
But
incorrect to use
that's
it.
question begging though, because the whole issue is which of these is the correct way to describe the system. So which rule is being implemented? So you say if there is no exclusion principle written down inside the language of the system, then it's doing addition. Whereas I, the designer, say, look, I'm not going to write down the rules. I'm going to build it into the hardware that it follows this rule by having it break down at a certain point. So I'm going to build the rule into the physical functioning of the system, sort of like card or something like that, where you build the system itself to implement a certain program without writing the rules down. It's the way the thing is structured that is the following of the rule. So here also could be a clever way to have the rule implemented, the exclusion rule, the exception, sorry, not exclusion, the exception rule. One way to do it is write down the sentence. If the number is greater than 55, then return the answer 5. Another way to build that very same rule into the system is have it short circuit when you enter those numbers. Then you have the same thing. So it's
Sure,
just a
but
clever way of implementing this rule. So you can't tell by looking at the system malfunctioning whether it was performing addition correctly and malfunctioning now, or whether it was performing quaddition and working right now.
Sure, if we bring that back into the perspective of like a human, say I'm doing addition, but I've been programmed to die once I get to 37 or whatever. I don't want to die. I'm doing addition, not quaddition, because I don't want to die. But the programmer has designed me to die once I get to 37, so I'm doing quaddition or whatever. I would say, no, that person is doing addition. And then the designer made a system where that person plus their death is doing quaddition. And so, from the perspective of the individual doing the numbers, what are they doing? They're doing addition.
So, I mean, we have been circling around this point for a long time, but um, why are you justified in thinking that you're doing addition? I don't see why you get to say that. So you don't know what the intention of the designer was. I mean, that's the whole kind of point of this argument, is that either you say, look, I live in a community and the community expects a certain answer. They expect me to say 125 when I add 57 plus whatever, 60 something. So they expect that. So therefore I'm correct when I say it, because the community expects me to continue on in a certain way. So okay, but factoring out that the community expects me to continue on in a certain way, then it's just kind of by stipulation that you say this couldn't have been built in the following way.
Well, it's not that they couldn't be built. It's more like if the designer's goals usurp the goals of the object, um, I think that if we're asking the question, what is the object doing? The object gets priority. So if I'm the object and I'm doing addition and says never stop, and the designer said I'm gonna die and it stops. If the question is what is the object doing? Seems I take priority. My intentions take priority. And so I get to determine I'm doing addition because I have this principle that says never stop. It's in my brain. I'm doing this. And even if I was designed to break down by some other thing, what am I doing? I'm doing addition.
So you get to determine which function you're implementing, even though you might have been designed to implement a different function.
Yes.
But that seems a bit like, I mean, I don't understand how you get to say that, because what you're just saying is, no matter how you built me, I'm still working incorrectly when this happens.
Yeah. So like if I have an intention of doing math that goes on forever, but my designer has an intention that I die after 37 or something. And the question is what am I doing? It's a question of ownership, I guess. Who owns the I? And so I would say the ownership is of the conscious individual in that case. So the individual determines what they're doing. And then you could
Yeah.
say um, the individual is doing addition, but the system, the individual plus the death, which was controlled by the designer, was doing quaddition. And so the individual was doing addition.
But why do you get to make that distinction?
It just seems like the context of when we ask what is the object doing, the object seems to be the priority or the significant factor in there, and not the designer. So we're asking like, what did the designer make the system to do or something? That's a separate question than what is the object doing. The object being the significant thing, the determining factor of what it's doing is takes priority when you just ask the question that way. What is the object doing?
Right.
Versus if you ask the question, what did the designer make the system to do something? And so it
Well,
seems like
I
just the
mean,
way the
the link
question is
between the
phrased.
two, the link is between the two is supposed to be that what the system is doing is what the designer intended it to do.
And I think that
So if they
maybe
intend X, then it's doing X correctly. If they intend Y, then it's doing Y incorrectly.
and I think that may be the one of the key distinctions, because I think when we ask what is the object doing, we ignore the designer entirely. It's just the way the question is phrased seems to me to be focusing on what the object's intentions are, I guess, rather than the designer's intentions. And if we phrase the question differently, then we could prioritize the designer's intentions. And so I think maybe that's why the rule following it doesn't make as much sense to me, because when you ask the question, what is the object doing? To me, the object as an entity takes priority over anything the designers. I think designers are just irrelevant. I think
Yeah. But the object, see, you're defining what the object is. You're saying that's sort of what you already admitted. I thought that the object just is the internal states of the object. But the whole question is, what about the internal states tells you one way or the other? So you say, I'm intending to do addition. Then the skeptic says, are you sure you haven't been intending to do addition, which is intending to do addition up until a certain number and then intending to do quaddition afterwards? So there's a kind of way that you try to reformulate some priority of yourself. The skeptic is going to come along and say, yeah, but there's these interpretations of what you're saying that you can't rule out, like that you were schmintending as opposed to intending, or to schmintend, like I said, is to intend to add up to a certain number and then do quaddition after that number. So given that you've never passed those numbers, you don't know whether you've been intending or schmintending. I mean, that's the every word that you pick, the skeptic's going to play that same game.
right.
Because remember, it's all semantics. It's about what do the concepts mean, what do the words mean, and are you actually aligning yourself with the right ones or making a mistake? The central question is always, are you adding correctly or doing quadding incorrectly? Are you doing quaddition correctly or addition incorrectly? And which one of those you say seems to depend on how the thing was built. And you don't have to like forget, this isn't necessarily an argument for God. By the way, in our previous discussion, I was never meaning to, I don't believe in God, obviously, but I wasn't ever trying to suggest an argument for the existence of God. I was trying to suggest that this is, something that the precepts can kind of get you with, because you have to kind of presuppose a bunch of stuff, what you're doing, by the way. So without all those
I have zero
presuppositions,
presuppositions.
but you just did make a presupposition that it's the person that they get to have priority. Whereas the skeptic comes along and says, is challenging your priority and saying, how do you know that you have been doing intending versus smintending, that you've been doing addition versus quaddition, or any of these things? And there's nothing in your past history which really tells us the answer to that question. So the past history of the person, everything internal to you, is compatible with it being designed in one way, but also in a different way, which I thought you already said.
Yeah, so I agree with
I thought you agreed with me,
matrix.
so that's why I'm confused, because it seems like you keep agreeing with the argument, but then saying I'm not agreeing with the argument, because you basically say, "Don't call me Darth Dawkins, jeez, what the fuck, dude." That dumbass can eat a dick. That's not me. This is a serious argument. Kripke's a serious person. He's a genius. You may think word games are not fun, but this is a question about how meaning and rule following are related to each other. And while no one is convinced of this argument, I've never met someone, by the way, who says, yes, I'm a meaning skeptic and I'm convinced by Kripke's argument. I've never met that person. But I've also, not even Kripke, Kripke himself, up to the day he died, I was in his class pretty much up till that point. He says, I don't know what, but there's got to be something. But the one thing that I am convinced of is that while everyone is unconvinced of the argument, no one has pointed out a convincing response.
Right. And so
So that's really what I'm pressing. I mean, obviously we all want it to be wrong, but it's like, where in the argument do you get out? And I see what you're saying as kind of giving into the argument.
Well, I'm saying all language and meaning are determined by something more primitive, physics. It's determined by physics. And intentions are also determined by physics. So if the designer that has intention, that's determined by physics. So it's all physics. I think that all of meaning comes down to physics.
Yeah.
And so I think we can look at the system and know what it's doing by the physics. And I think the problem is more how to communicate that effectively in relation to the arguments. Because I still don't see a problem with understanding that. Can we know what rule a thing is following, yeah, it's doing whatever its physical parts are making it do. That's the answer. And
Right.
some
But
abstract
that's it.
rule
That's
that's been placed on that is a separate thing. It's not following this abstract rule that we place on it. It's following the physical constituents of its parts. And the abstract rules are just there is no such thing. It's the physical parts are the meaning.
but the physical parts leave open these two interpretations, so they can't be the meaning, is the argument. That
And
just
that's the part
looking at the physical parts leaves open whether it's functioning correctly or incorrectly at a certain point.
I disagree with. I think that's, can we interpret the actual meaning in multiple ways? Yes. Does that mean the actual meaning is incorrect? No. That's the way I
Right,
interpret
but
it.
what in the system makes that true?
I'd say the
There's
physical
nothing
parts of the
in the
system.
system which rules out what I'm saying or what the Kripkean argument is. And by the way, just because no one agrees with this doesn't mean it's sophistry. I mean, Hume is a
Right.
skeptic. He's not a sophist. The puzzle is a challenge. The fact that no one is convinced just means that they don't have a good answer. I mean, you could say, I don't know why, but it's got to be, but that's not really a good answer. So what we're looking for is a good answer, one that says, yes, in fact, these states in the system rule out and make that over there a malfunction. But it doesn't seem like that you can find anything like that.
How this be from different from saying whether or not we're in the matrix? There is a fact of the matter whether or not we're in the matrix. We just have to know what the rules of the system are. Whatever the fundamental nature of reality is, we answer the question. Why would that same thing not work here? Which rule does it follow? If we know all of the facts of reality, there is an answer there.
Yes, including how it's built and whether um, it's doing what it was built the right way. So if you knew that, then you would have an answer.
Well, presumably there isn't a
So
designer.
that has to
No.
bring in the intention of the designer. Otherwise, you can't answer that question.
Well, the designer was built by physics, presumably. So the designer is just a result of physics. And so the designer doesn't seem to be the base thing we're looking for. It seems like there's something more prior to the designer that we would look at to know the physical rules that it's following. And that's
Well,
the
we'd
thing
want
I
to
think.
know. I mean, it depends on whether you agree that the question is whether it's working correctly or not. Because
Yeah, the correctly part I
that's
don't
the
think
whole
I've ever
question.
really yeah, the correctly part I don't think I've ever really thought about as much. It's more like, can we know what rule the object is following correctly? Uh yeah, I don't think the correctly part fits into my worldview. It's like whether it's doing it correctly. Like, because
But
you
it
could be
has to,
doing why? Because you could be
because
doing,
otherwise you can't say what it's doing. You can't. So, oh, by the way, I won't stop looking at the chat because I'm interested in what people who are intelligent and informed have to say. So far, certain people in the chat are not meeting that standard, and other people are. And I'm very interested in what they have to say. So that's not going to stop. However, the question here is in a given case where the system seems to be malfunctioning, is it in fact malfunctioning? That's the question. So you cannot really do this without answering the question, is it working correctly at this time when it seemingly breaks down?
so what comes to mind is
That's,
like, if I'm doing addition and I keep going past 50 to keep 56, 57, whatever, and don't go back to 5. I'm doing addition correctly and quaddition incorrectly, but which one I'm doing seems to be determined based off of my intent. So if I want to communicate addition to you, I'm doing addition correctly. Even if my designer designed me to do quaddition, he doesn't matter. Who cares? What matters is what I'm intending to communicate.
because the reason why we're supposed to care is because at a certain time where you think the thing is breaking down, the designer might have made it work that way on purpose, so it's not breaking down. That's the whole That's kind of the crux of the entire issue is, are the things which you would point and say, this is a mistake, are they mistakes or not?
Well, so that seems like a different question, because I was always focused on the question, is there something about it we can tell which rule it's following?
Yes.
And that seems like a different question than, is it doing one correctly, which is the correct rule.
But the reason why they're not separate questions is that this breakdown case has to be interpreted as a mistake or not a mistake. So it's either part of the design of the system and doing what it's supposed to be doing, or it's not part of the design of the system, and at this point, it's not doing what it's supposed to be doing. So the question is, when the system breaks down, is it working correctly? So that's how they get in. So because someone could have built it that way so that it actually is supposed to break down at that point and therefore working correctly at that point.
To be fair to the chat, that does sound very much like the halting problem.
Why?
Because you're asking when the system stops.
The halting problem is whether you could formally prove that the system ever stops. That's not what we're talking about. I'm not talking about formally proving anything.
Well,
So that's a completely different question. It's confused to make that statement.
Did the system stop or did it break? Is it still going? Is it just still going? That's a part of the system. That's when it answers.
The question is whether the stopping, the breaking down part, by the way, the halting problem doesn't have to do with anything with the thing breaking. It has to do whether there's an entailment of the program that it stops. That's a different question. The question that we're asking here is,
you're saying that the breaking was a part of the program, right?
I'm saying it's compatible with it breaking, that it was part of the program.
That would be the same as the halting problem continuing in that case, right? The stopping was a part of the program in that case.
The halting problem is about whether you could formally prove that any given program will halt.
Yeah.
The question here is, what program is the system implementing? Different questions. And the problem is that a smart person can make a program being implemented by doing something that you would think of as breaking down. So that you say the system is broken, but it's actually doing what it's supposed to be doing. It's not broken.
All right. Well, we've been going for about 2.5 hours and I have to get to work pretty soon.
Okay.
I don't think my position has changed. I still don't understand that part of the argument. Still, for me, it's like, if we look at the physical system, we know which rule it's following, whether or not it's programmed in or not. And the breaking, I would count it as an externality just on how I understand the words to mean. But I don't have a further way to explain that because I haven't thought about that more.
That's just, that's just question making. So you can say that, but that's not a good answer to the challenge, which is, what is it about the physical system that proves that it's working correctly at this time as opposed to incorrectly at this time, which is the entire challenge. But that's fine.
All right, well, I'll think about it more, try and think about it from the perspective of whether it's working correctly or incorrectly.
Yeah, cool. All right. Well, thanks for taking the time to have this conversation with me. And I'll be looking forward to hearing your further thoughts.
Sure. Thanks. I appreciate you coming on, and I will talk to you later.
Okay.